Hey, and hello there, everybody. Here we go. Here comes your warm-up. So your warm-up is right here. Consider the relationship of an oven. What can an oven do to the things you put into it? What comes out? Draw an oven on your paper. To the left of your oven, list 4 school appropriate, meaning don't commit any crimes here, that you could put into that oven. To the right, list the 4 things that would come out of that oven. Then list 3 things that cannot, not should not, cannot go into an oven. Okay. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? All right, Denise, what is something that you can put into an oven? Sure, dead chicken, like a chicken, right? Like a whole chicken. I would say a raw chicken. And if you put a raw chicken into an oven, what comes out, Denise? A cooked chicken, absolutely. Winner, winner, chicken dinner. Absolutely, cooked chicken. Beautiful. Absolutely, that is totally correct. Let's see here. Kari, what's something else you could put into an oven? You sure could put headphones in there. Should you put headphones in there? I don't think so. What would come out? Like melty plastic, like a puddle of plastic. A puddle of plastic is what I think would come out. Yeah, again, you shouldn't do that, but nothing's stopping you, right? They'll fit. Mesa, what else could you put in there? Absolutely, cookie dough. And what comes out? Heck yeah. Heck yeah, cookies come out. Absolutely. Let's get one more. Let's see if I can get that one from Will. What's the last one you could do? Sure. Magnifying glass. And I would actually say probably a puddle of plastic, right? A puddle of plastic would come out again, right? So I would actually say a magnifying glass and then again a puddle of plastic. So most of those that I've seen, like my little lady got one of those, like a magnifying glass, because she's way into Mira, Royal Detective. Anybody, let's hear it from Mira, Royal Detective. Mira, 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 Mira. Hey, no, no. Real quick, Mira, Royal Detective on your radar? Yes, no, anybody? Well, a little bit. Okay, okay. Maybe a little before. Anyway, but the little magnifying glass she got's all plastic. So maybe if you had like a really expensive one that was made of metal and like glass, it'd be something different. But the one I'm thinking of, puddle of plastic, makes sense to me. Yeah. Oh, just the same size as the one in your kitchen. Now let's talk about what can't go into an oven. So let's see here, Harper. What is something that cannot go into an oven? Now, if you went home and your folks were baking something in the oven and it was on, could you take your shoes, put them in there, and then like walk away? You sure could. Should you do that? No, you're going to get in huge trouble. If you put your shoes in there, I have a feeling ashes would come out. They'd probably catch fire and there's ultimately be ashes there. So you could. I don't think you should. Now, is there something that you can think of that you literally couldn't put in there, Harper? A car. You sure couldn't park your car in there. A car couldn't go in there. You know what else can't go in there? Like a mattress. You're not going to get a mattress in your oven. Can I tell you what my favorite answer to these questions, like in all time? One of my favorite answers to this question was the oven itself.
I put that.
Yeah, that's funny. That's funny. The oven itself. You can't put that in there. My other favorite one, you can't put happiness in there. You can't put happiness in your oven. So here's the thing. An oven represents a relationship with inputs and outputs. These are the inputs. It's what goes into my oven. These are the outputs, what comes out of my oven. Can I give you guys a little ninth grade terminology just as a little aperitif? No? Yeah, maybe? This whole set of the inputs is what's called the domain of the oven. More on that next year. Everything that comes out is appropriately called the range. Ha ha ha. And things that can't go in are outside the domain. Now, an oven is what we call a function. And the reason it's a function, guys, is because if I put in more raw chicken, what do I get out? More cooked chicken. And I put in more raw chicken, what do I get? More cooked chicken. Every time I put in raw chicken, I will always get cooked chicken. Every time I put in headphones, I'm going to get a puddle of plastic. Every time I put in cookie dough, I'm going to get cookies. Every single time. That's why that's a function. And more on that in just a second. All right, guys. It's the 84th day of school. Did you guys know that there's a town in the United States called 84, Pennsylvania? Its population is 645. How many of us are disappointed that the population wasn't 84? Or 840 or something like that? That would be fun. It's Write a Letter to a Congressperson Day. Yay! You know, I would write a letter to my congressperson, but since my mom told me if you can't say anything nice, don't say anything at all, I would just mail a blank slip of paper and be like, here you go. Interpret that if you would. Hopefully not as a threat. I'm not trying to threaten anybody. All right. What's our first essential question? I'd love to get that from Jude. Yeah, I know it's been a minute. Yeah, go ahead and write that down. How do we represent relations? As mapping diagrams. I forgot how to write. Mapping diagrams. Or sets of ordered pairs. Go ahead and write that down for me, guys. Thank you, Jude. What's our second essential question? I'd love to get that from Fatima. Oh, sorry, there's one before that. How do I tell if those relations are or are not functions? And then last but most certainly not least, Aurora, what's our last essential question? Yeah, what's new about the scoreboard game level 5? While you guys finish writing those down, our Jeopardy today is Elemental Table by price. It's number 2, HE, goes for about $40.39 per kilogram. It is helium. It is helium. How do you weigh helium?
You just do.
I don't know, like, how do you put it on a scale? Like, that confuses me.
You take like a big balloon.
Uh-huh.
And then you like make it so it doesn't weigh the balloon, and then start filling the balloon with helium.
I guess that might work, but then you have to, I don't know how to tip your scale upside down. Yeah.
Just like you put it in the canister and then you weigh the canister.
Oh, that could work. I wonder if that works. I wonder if that's how they do it. But also over here, guys, that is a paint. Paint is a way to cover a wall for our Pictionary. So before we get into our lesson, guys, let's talk about Scoreboard Game Level 5. Now, Scoreboard Game Level 5 works very much the same way that Scoreboard Game Level 4 did, meaning when you're doing things that meet my expectations, like writing down your essential questions and being quiet while I'm talking to you, for example, right now, you get a point over here on the happy side.
Oh, yeah!
We still have the star team and the moon team for people who are doing a really good job meeting my expectations or having a hard time meeting my expectations. People on the star team end up over here. People on the star team are allowed to, at the last 5 minutes of class, wander around and use their phone. Also, whatever group happens to be winning by the end of each day, they also get to do that in entirety. So let's talk about what happens in Scoreboard Game Level 5 that's a little bit different. The first thing that is going to be different is that I need to start referencing our what do I need board a little bit more. So every day I should be referencing this thing. So today we need our pencil and our math notebook. There, I did it. Now when the bell rings to leave, if I have not referenced this, then our group, our period is going to get 2 extra points. I'll just put 2 extra points on there and an extra accent card for the next day. Okay, like so that means there'll be 2 accent cards there. I need to reference that every day, and it needs to be accurate. Like if I messed up, like if that said calculator, even though we don't need our calculator today, then that same thing would apply, right? Let's see here. What else is different? Oh. So you know how the winning group, like let's say second period has 12 points, third has 5, fifth has 7. When we are the winning group, everyone gets to wander around and use your phone in the last 5 minutes of class. In scoreboard game level 5 and above, any period that has 7 or more points gets that bonus. Any period that gets 7 or more points gets that bonus. So the score is like 4, 12, 8, 7, 3, 8. All those periods that have 7 or more points get that bonus. Now you might be wondering, then who cares if we're winning, right? What's the point of winning if everyone who gets 12 gets it? I'll tell you what the point is. 7, excuse me. Everyone who gets 7 or more gets the bonus. The point of winning is this. When you are the winning period, everyone on the star team for that period, I will open up a little voting thing where they can do this. They can unlock Mr. Petersen's unlockable accents. Like right now we have hippie, French, Texas, Scottish, and hippie. Right? No, I didn't hippie. Hippie. She's in there somewhere. It's hippie, Texas, Australia. So this is Mr. Petersen's unlockable accent deck, which has like pirate. I have to speak in Spanish. The infamous chicken. The singer. Boston drill sergeant. Jamin. I'm on a roller coaster. Batman's in here. This one. Mr. Snyder, right? So, anyhow, if you're the winning group, then at the beginning of the next week, you guys get to vote on which one's the unlockable accent, and then that accent is unlocked for the rest of the year. Okay? Make sense? Perfect. And then also, just so you guys know, I saw earlier today that there's no announcements today, so no announcements today, and we'll get that figured out. That being said, guys, let's get to it. Underneath all this, got a pencil? Got a pencil? Okay, today's topic is functions as mapping diagrams and ordered pairs. Whew. We're going to talk about relationships as mapping diagrams and ordered pairs. And we're going to start with mapping diagrams. So we're going to write mapping diagrams. This is just a way to represent relationships visually. So that we're not having to do, I don't know if you remember the little Petersen's function factory, you put stuff in the top and it comes out the side. It's really annoying to draw, and even that oven was kind of obnoxious. So we're going to simplify that a bit using what we call mapping diagrams. Mapping diagrams look like this. There's two ovals. That is a circle. You draw two ovals nearby, near one another. And one of the ovals is going to represent your input, and one of the ovals is going to represent your output. Your input's going to be words, your output's going to be numbers on this one. And let's just go ahead and see if you guys can catch on to the relationship. Let's see here. Jude, give me a word.
Trampoline.
Trampoline. So the input is trampoline. And the output would be 10. I recommend doing the oval because that's how these generally get going. When you're doing them yourself, I welcome you to it. Now, to show that if the input is trampoline, the output is 10, we use an arrow to draw a line that goes from trampoline to 10. Trampoline to 10. Fatima, give me another word. Box. If the input is box, the output is 3. Let's see here. That's going to be... Aurora, give me another word. Christmas. Nine. How many of you think you see what the relationship is here? How many of you think you see what the relationship is? Audrey, what do you think it is? Yeah, exactly. So, for example, if the word was mad, what would the output be there, Audrey? Yeah, and do you see how we already have a 3 in our outputs? That means that we can just point to the 3 anyway. So you don't have to worry about those repeats, right? That's what helps us out with that. Will you guys do me a favor? I want you guys to add one word of your own into the input and then have your output on the other side for me. And then show your partners and make sure they agree. Then talk to each other. Is this a function? If I put the same thing in, am I going to get the same thing out every time? Talk to each other, and here we go. Teach! Oh, that's Maya's. She was not here today. Okay. Can I get you back up here in 5, 4, 3, 2, 1? Ben, what word did you put in there? Buster, absolutely. As in Buster, comma ghost. And that's 1, 2, 3, 4, 5, 6. So that's that. Now here's the thing, guys. If the input is what is that? Hey, I want that arrow. There we go. I don't know why I was doing that. If the input is Buster, the output is 6. Now, if I put Buster in there again, what is the output going to be? 6. That means that this is a function. Since every input gives me the same output every time, box goes in, 3 comes out. Box goes in again, 3 comes out again. That is indeed a function. So we're going to write down this is a function. This is a function. Let's do another one. So go ahead and draw another pair of ovals here. This time, the input is going to be a food. And the output's going to be whether or not someone likes that food. So, let's see here. I need some food, and so, well, not like literally, but Max, give me a food. Tacos. So if the input is tacos. Preston, how do you feel about tacos?
Yes.
Yes. The input is tacos. The output is yes. Preston, give me a food. Steak. Okay. Let's see here. Now I need a little bit of help, and this time it's going to come from Edie. How do you feel about steak? Yes or no? No. She says no. Why does it keep doing that? Like, does this weird line thing. There we go. So steak and no. Edie, give me a food. Quesadillas. Gonna make me spell quesadilla. See, quesadilla. Quesadilla. Right? Like that. Okay, quesadillas. Quesadillas. Let's see here. I need a little help here. Josie, quesadillas, yes or no?
Yeah.
Yes. Okay. Now, guys, right now, this appears to be a function. When I put in tacos, I get out yes. When I put in steak, I get out no. When I put in quesadillas, I get out yes. Now, guys, let's just say I played this game for the rest of the period. Number one, that's a weird thing to do. But number two, do you suspect that this would still be a function by the end of it? Show me the thumbs up. Yeah, I'd be a function. Show me the thumbs down if you think it would not be. Look at all those thumbs down. Talk it out. Teach, teach. Hey, teach, teach. There you go.
Guys, it would not be a function.
So we're trying to decide if this would be a function if we just kept playing. If we kept playing.
It's because there's only
Okay. Can I get you guys back up here in 5, 4, 3, 2, 1. Ah, what a great countdown from 5. But we got to work on those teach okay moments, right? When I say teach, you say okay, and we do all those things. Dominique, do you think this would be a function over time? Okay. So wait, how do you feel about steak? Yes or no? No. So that's a good thing. Jane, how do you feel about steak? That's a no. Mesa, how do you feel about steak? That's a no. How about you, Archer?
Yes.
So there you go. The problem is that there's this thing where if I'm asking people how they feel about something, the reason I got no is because apparently there's this loop right here, this L-shaped folks here who don't want steak. But I could just as easily have asked someone and they might have said yes, right? Archer likes steak. I love steak too. I have a feeling Preston does too. Because I think most people are picking foods they want because they're hungry, right? Most people are picking foods they want to eat because they're hungry. Like, I don't know. I'll just pick, how about this? My input, salmon. My input, salmon. Who here likes salmon? Who here does not like salmon? You see what I mean? Whether I get a yes or a no depends on who I call on. If I call on me, you get a big old yes. I love salmon. Looks like if I call on Kari, you were saying a no on salmon, right? Yeah. If I call on Kari, I'm getting a no. This would be a non-function. This is not a function. And the reason is because I have a single input, steak, with multiple outputs, yes and no. A single input, salmon, with double outputs, yes and no. Nobody here actually hates tacos. That can't be. Is that true? Anybody here not like tacos? I was going to say, tacos are pretty universal. It's like tacos and pizza. It's hard to find someone who doesn't like those things because they are delicious. They are delicious. So I suspect that if we were only asking about tacos, we'd be fine. Unless they were like salmon tacos or something. Okay, that's the idea. Oh, man, I'll mess up some fish tacos.
What about the output of depends on how I feel?
That's true. And that's another thing. Carson's absolutely right. How many of you are like, I like salmon, but not necessarily right now? Well, right? Like, I don't, like, yeah, it's kind of weird to eat salmon, but at 9:15 in the morning, I think. Anyway, let's keep this going, guys. Got a pencil? Okay, here we go. Okay. Here we go. Here's your inputs. 1, 2, 3, 4, 5. Here's your output, 0 and 1. So this is how it works. So if 1 goes in, 0 comes out. Go and draw that for me. 1 goes in, 0 comes out. 2 goes in, 1 comes out. 3 goes in, 0 comes out. 4 goes in, 1 comes out. 5 goes in, 1 comes out. My question is this a function? Yes or no? Let's see with your thumbs. Yes, thumbs up. No, thumbs down. Look at that. We got a mix. I see thumbs up and I see thumbs down. Is this a function? Yes or no? Why or why not? Teach, teach. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Let's see here, guys. Thumbs up, that's a function. Thumbs down, that's not a function. How do you guys feel? Let's see it, everybody. Let's see it, everybody. Take a guess. It's okay to be wrong. Thumbs up, that's a function. Thumbs down, that's not. What do you guys think? What do you guys think? What do you guys think? It looks like we're mostly saying yes. Yeah, this is a function. This is a function. And the reason is, guys, I know what you're thinking. How many of you really wanted 5 to go in and 0 to come out? How many of us really wanted that to happen? Yeah. And it didn't meet our expectations, but that's not what makes it a function or not. What makes it a function or not is if 5 goes in, what comes out, everybody? If 5 goes in, yeah, and if I put in 5 again, what comes out? Another 1. That's why it is a function. That's why it is a function. Let's see here. Oh, yeah, there we go. All right. Let's see here. I got one more of these for you, and then we're moving on to the sets of ordered pairs. Got a pencil?
Absolutely.
Here we go. Let's see. I forgot. Got it. Okay. So the inputs here are going to be -6, -4, -2, and 0. The outputs are going to be -3, -2, -1, 0, 1, and 2. Heard some people make a sound like that. This should be alarming. There's something here that is unusual. So, I'll tell you right now. Go ahead and write that down, guys. Inputs -6, -4, -2, and 0. Outputs are -3, -2, -1, -0, 1, and 2. If 0 goes in, 0 comes out. If -2 goes in, -1 comes out, and also 1. If -4 goes in, -2 comes out, so does 2. Oh, I forgot to put a 3 down here. My apologies. If -6 goes in, -3 comes out, and so does 3. My question is this a function, yes or no? Why or why not? Talk it out. Is this or is this not a function? Why or why not? Teach! There we go. Okay, talk it out. I heard yeses and I heard nos. What do you think, Nora? Okay, sure. Well, it's kind of like when it's like, hey, it may or may not rain. You're absolutely right. It's gonna. One of those things is gonna happen. What's your instinct telling you? That it's a function? How come? Aha! There's the problem. There was a problem in that. We'll talk about it. Okay, come on up in 5, 4, 3, 2, 1. Let's see those thumbs. By the way, that was a really good teach. Okay, good improvement on that. You guys deserve a point for it. That was a really good mighty. Oh yeah, way to go on that, guys. Big improvements. Let's see those thumbs. Thumbs up, that's a function. Thumbs down, that's not a function. What do you guys think? What do you guys think? What do you guys think? A lot of thumbs up, a lot of thumbs down. Kenley, what makes you think that's not a function? So that's okay. That's okay. Now I'll tell you, I actually love that you said that, because here's the thing. Being a function or not actually doesn't have a lot to do with making sense. That's actually kind of why I did this one, is because if it made sense, odd numbers would go to 0 and even numbers would go to 1, but it didn't do that. But if 5 goes in, 1 comes out. 5 goes in again, 1 comes out. Answer me this, Kenley. If -4 goes in, what comes out? Anything else? Let's see here. I think it's kind of like to the 2 there. That's okay. That's the problem. The reason it's not a function, Kenley, is because if this one thing goes in, multiple things come out. And that's a problem. That's what makes it not a function, is that if one thing goes in and multiple things come out, that's not a function. It's okay if lots of stuff goes in and they turn into the same thing. Like I remember the terrifying oil machine. Yeah. A lot of things can go in and make the same thing. The problem is one thing can't go in and make multiple deals. That's no good. That's why we say this is not a function. Not a function. Okay. Let's talk about sets of ordered pairs. All right. Got a pencil? So we're going to talk about sets of ordered pairs. And they're like this. We put them in curly brackets to say that they go together. And every single one is an ordered pair, input, comma, output. This went in, this came out. That's the relationship we're talking about. Hey, that rhymed. All right. So here's the relationship we're going to start with. I'm going to draw a card, and you're going to tell me a color. I'm going to close my eyes. I'm going to open them, and the first person I see wearing that color, that's going to be the output. Okay? So, let's see here. I want a color, and I want it from Kieran. Give me a color.
Lime green.
Lime green? I don't know if anyone's wearing lime green. Okay. There we go. Yeah, Kieran's got lime green laces. So, lime green, comma, Kieran. Beautiful. Okay. Let's see here. How about I need a color, and this one's going to come from Catherine. Give me a color. Red. Okay. Catherine's. Red, comma, Catherine. I see how it is. Red, comma, Catherine. Let's see here. How about I get one? Lucy, give me a color. Blue. So, blue, comma, let's see. That's kind of a blue, right, Izzy? That's like a navy blue. Yeah. I don't know. I didn't see Josie in time. Okay. Well, but here's the point. Here's the point. If I asked Izzy for a color and she said blue, all of you guys were really mad at me because who else is wearing blue? Archer. Sure he is. He's got blue. See? There you go. All the little strings that says champion in blue right there. Also, Josie's wearing blue. I could have just as easily seen Josie. Will's wearing blue. Now, the point is this, guys. I would say that this is not a function. Will you guys talk to each other? Why is this not a function? Teach! Sure, I was waiting for someone to say black because it's like a lot of people here are dressed for a funeral. Oh. All right. I have drawn this guy. This is the Australian card. So, all right, everybody, can I get you up here in 5, 4, 3, 2, 1? All right. Carson, why is this not a function? Beautiful. Exactly. There's multiple outputs for a single input. When I put in blue, I get out easy. But when I put in blue, I get out at you. That makes this not a function. This is not a function because a single input has multiple outputs, and that's a problem. Let's see here, guys. So let's look at some other ones and see what we think. Let's see here. Got a pencil? I've got a pencil! Here we go. This is going to be 0, 0, 1, 2, 2, 4, 3, 6, 4, 9. Okay. When I say teach, I want you to say, okay, is this or is this not a function? Teach! You guys think, is that a function or is it not a function? All right. Can I get you guys back up here in 5, 4, 3, 2, 1? Izzy, do you think that's a function or not? Right, it is a function. How do you know it's a function? Exactly. Every input's got its own output, and that's all right. That's a function. Is a function. Okay, I got 2 more for you. Right, here's the next one. -2, 0. -1, 0. 1, 0. 3, 0. 4, 5. Is that or is that not a function? Why or why not? Teach! Why not?
It was a function, but
Did it? I don't know. Talk it out. Yes, exactly. Let's see here. Can I get you back up here in 5, 4, 3, 2, 1? Nora, is that a function? Yes or no? Yes, it is. It absolutely is a function. Can you explain why? Exactly. Every input's got its own output. It's not about whether it makes sense. It's about whether if 1 goes in, 0 comes out. 1 goes in again, 0 comes out again. It's okay that these are all becoming 0. What wouldn't be okay is if your one input was becoming multiple outputs. Last one we're going to talk about today. We have to do 2 things to it though. So 2 more things, one last thing, one last ordered pair set to write down. Here we go, guys. Here's your inputs. It's 4, 2, 1, 1, 0, 0, 1, -1, 4, -2. Is that a function? Yes or no? Why or why not? Teach! There you go, Kieran. Kieran's got it. Kieran's got it figured out. Nora as well. Nora's really got it going on with it. Absolutely. Your instincts are serving you well, Nora?
What?
Your instincts are serving you well? Because you were like not sure, but you were right about it. You were right. Your instincts were right, because it's weird. We either want those all to be 0, or we don't like that there's a bunch of zeros, you know? It's a little tricky. Okay, can I get you back up here in 5, 4, 3, 2, 1. Okay. Audrey, is that a function? Yes or no? It is? Why? Careful now. So every input's got an output. That's true. But watch this. Audrey, if I put in a 4, what do I get out? Anything else? That's a problem. If I put in a 4, there are 2 different results. I might get out a 2. I might get out a -2. That's why this is not a function. It's because when my one input of a 4 has multiple outputs, that's causing problems, not a function. Not a function. Now the last thing I'm going to ask you guys to do with this is we're actually going to translate this ordered pair set into a mapping diagram. So give me one last mapping diagram. Last thing I'm going to have you write today. Take a look here, Audrey. Audrey, what are all the possible inputs I've got in me ordered pairs here? Perfect. And what are all the possible outputs? Excellent. So that's how we set it up. All my inputs go on the left. All my outputs go on the right. Now, if I put in a 4, I get out a 2. So I mark it like that. I put in a 1, I get out a 1. Put in a 0, I get out a 0. But if I put in a 1, I also get out a negative 1. I put in a 4, I also get out a negative 2. That makes sense, guys. How many of us are feeling like, hey, it's not too bad? That's honestly, guys, this is how you're going. This is part of getting a 3 on your skill check next week, or maybe the week after even. But that's the idea: is can you identify these? Can you work with them? Okay. How many of us are feeling pretty good about that? Great, guys. We've got a little bit of extra time here, but honestly, I feel good about it. What I want you guys to do is I want you to hang out in your assigned seats and just talk to each other here for these last few minutes. What is it? It's Nora and Kieran cannot be up and moving around, but everybody else hang out in your assigned seats, and I'll dismiss you.